In this podcast, we're going to give really an introduction to metabolism, just like the title suggests. We're going to talk about digestion, and we're going to talk about how we get products that can then be used in aerobic respiration. We'll touch a little bit on coenzymes as well, and give you a rough overview of glycolysis, citric acid cycle, and the electron transport chain and oxidative phosphorylation. All right, let's start with definition for metabolism. This is the sum of all chemical reactions that provide energy and substances required for all growth. Metabolism can be catabolic or anabolic. If it's catabolic, you have complex molecules being broken down into smaller ones. When we break them from large molecules to small molecules, we are releasing energy. So these are exothermic. An example would be having a long chain of polysaccharides, so you have glycogen, and breaking those into monosaccharides like glucose. When you break those bonds between your glucose molecules, you're releasing energy. Those glucose molecules can be further broken down, but it's a way for the body to provide energy. Another example would be lipids, triglycerides getting broken into a glycerol, and 3 fatty acids. Those are all catabolic because we're breaking them down. Anabolic metabolism is where you form large molecules from small ones. In order to do this, you're going to need an input of energy, and energy gets stored in those bonds. A good example of this would be the formation of proteins from amino acids. The way that I keep these two straight is I think of catabolic having the word cat in it. I don't know about your guys' cats, but I had a cat that used to break everything. So whenever I think of catabolic metabolism, I think of him breaking things down, which reminds me that catabolic is complex molecules being broken down. Anabolic, I'm most familiar with this term when it comes to anabolic steroids, which are something that bodybuilders use to get bigger muscles. So you're building bigger muscles, and that helps me to remember that anabolic metabolism is the building of complex molecules from smaller ones. Metabolic pathways or biochemical pathways are a series of reactions. They have a very specific order, and there are a lot of intermediates to get you from point A to point B. Sometimes they're linear, where you're going to generate a final product different from what you started with, so it's kind of a one-direction pathway. Other times they can be cyclic. And in a cyclic biochemical pathway, you're going to have to regenerate your original reactants in order to go through the cycle again, to use that biochemical pathway again. All right, so we can get some energy from locations other than the mitochondria. We know we can get a couple ATP through fermentation in the cytoplasm, but really the mitochondria is the site of energy conversion and production. Please, please, please replace your definition of the mitochondria as being the powerhouse of the cell with this one, because it's the site, it's where all that energy is produced for an organism. On the next slide, we're going to look at the structure, and the structure is very important for why we get so much energy from the mitochondria. We use coenzymes to shuttle electrons from one location or one biochemical pathway to the next, because we can use them to do work. Electrons are high energy, they do work for us. So NAD plus and FAD minus become reduced. Reduction means we're gaining electrons. When we gain electrons, they take on the form NADH and FADH2. This is very important for us. Let's look at this reaction just so you can get an understanding of why we pick up one proton versus two. NAD plus has a +1 charge. It picks up 2 negative charges. So therefore, if we were to just leave it as is, the overall charge of NADH would be a -1. So we also pick up a proton with this, which will give us an overall charge that is neutral. So 2 electrons get picked up from whatever biochemical pathway you're on. They get shuttled into the mitochondria where we can use them to do work. Let's look at, not lowercase, FAD minus. Okay, so this has a -1 charge. We know it's going to form FADH2. So we had to add 2 protons in. We have a neutral charge, so we have 2 positive charges here. So How many electrons get picked up by FAD minus? That's going to have to be 1 electron with an overall charge of -1 as well, and that's the only way we're going to be able to get that neutral charge. So FAD minus will carry 1 electron, NAD plus will carry 2 electrons. And again, the whole purpose is to shuttle those high energy electrons from one location to the other. I like to think of these guys as being similar to your moms with their minivans when you're in middle school. The NAD plus acts like your mom's minivan. She picks you up from the house. She takes this high energy middle schooler, drops them off at school so that they can go do work. That minivan is just shuttling you from one location to another, and that's what NAD plus does. It shuttles those electrons from one location to another where they can do work.